Today's lesson is on the triangle inequality theorem, and by the end of the lesson you will be able to state the theorem and apply it in various situations. Before we talk about the actual theorem, let's go back a little bit in time. Here I have 3 points, and I'm just placing them on the table. My question to you is, can I form a triangle? And if you remember back to the beginning of the year, we did a number of problems like this where we were given 3 ordered pairs. We were given points on the coordinate plane, and we were asked, given 3 points, could we form a triangle? And we discovered that yes, in fact, we can form triangles with one exception. The exception was if the points were collinear. And we used the slope to determine whether or not the points were collinear. And if they had the same slope, then they were collinear and we could not form a triangle. And we stated a postulate that any 3 non-collinear points could form a triangle. Alright, so today we don't want to talk about points, we want to talk about sides. Now the sides of triangles are line segments, and here we have some not exactly line segments because these guys have thickness, and line segments only have length but no thickness. But in order for us to see the line segments and move them around and have dimensions on them, they do have this thickness, but we're just going to have to imagine. Alright, so my question to you is, if I choose 3 of these line segments, could I form a triangle? These are 2 inches, 3 inches, and 4 inches long. So 2, 3, and 4 inches long. And we can see here that even with the thickness, yes, we have a triangle. All right, so, and of course we know our 3, 4, 5 inch triangle should give me a nice right triangle here. And there's our 3, 4, 5 triangle. What about if I'm just going to pick the 2 4s here. Now, can I put a 2-inch side between them? There we go. So 4, 4, and 2 form a triangle. What about 4, 4, and 3? That looks good too. What about 4, 4, and 5? There we've got another triangle. But you see the shape of our triangle is changing while they're all isosceles. This, I think our next one is going to be an obtuse isosceles. And this is 4, 4, and 7. Now, I think you can start seeing that there will come a time when this side, if I have 2 4-inch sides, this side will be too long. And my question to you is, when will that happen? If I have a 10-inch side, will I be able to form a triangle with 2 4-inch sides? And the answer is no. Alright, so it's time now to think about our triangle inequality theorem. So it is an inequality. This side here, it worked with a 7 and a 2 and a 3 and a 5, but I could not fit the 10. What is the largest side I can fit between those 2 4-inch sides? Well, I think that you can see that if I add these 2 together, I would have an 8-inch side. And if I had an 8-inch side here, there would be no ability to bend. So the third side of a triangle must be less than the sum of the other 2 sides. And that is our triangle inequality theorem. So when we're looking at this, let's just take another example here. If I have a 5-inch side, and let's use the 4-inch, and the 4-inch, could I fit my 10 in? No. 5 plus 4 is 9. So this side has to be less than 9. If I have a 7 and a 5, could I fit my 10-inch side in there? Well, 5 and 7 is 12, so I should be able to get that 10-inch side in, and in fact I can. Okay, and that's all there is to the triangle inequality theorem, that the third side of a triangle must be less than the sum of the other two sides, or, said another way, I'm going to show you exactly how the book says it. Let me get a little closer here. There we go. The triangle inequality theorem says that the sum of the lengths of any two sides of a triangle must be greater than the third. So PQ plus QR must be greater than PR. PQ and QR must be greater than PR. And any two sides. So this must be true for any pair of two sides. It must be greater than the third. The sum of the lengths of any two sides of a triangle must be greater than the length of the third side. Okay, let's look at an example. And I'm just going to give you an example right out of your book here. Is it possible to form a triangle with the given side lengths? 8, 15, and 17. Okay. Is 8 plus 15 greater than 17? Is 8 plus 17 greater than 15? And is 15 plus 17 greater than 8? And there you go. There is your answer to the problem. I'm going to ask you to do a couple more examples. And then tomorrow we'll extend this. Okay.